So when we talk about surface area, our units are squared, and that's because when we think about the area of an object, we're thinking of it in terms of these squares that come up. So that deals with area. Now what we're going to look at is volume, which is the space that's taken up inside of the figure. So we want to talk about the space that's taken up by this three-dimensional figure, and with that, we start talking about, instead of just these single squares, we're going to start talking about cubes and really how many cubes can fit in the shape. So with that, when we get our units out for these, whatever units we're dealing with are going to be cubed. So let's go back to our cheerleading box and talk about the volume of it. So we talked about how it has a length of 4 feet, a width of 2 feet, and a height of 3 feet. Now what we can think of is how these dimensions kind of separate up this box. Like if I think about this length of 4 feet, it's like I can separate this up into units of 4 feet, and the height will cut it into units of 3 feet. So it's like we have 3 going up and 4 across. And with that, we could see our surface area coming through here with our length times height. But now let's see what happens when I bring width into the mix. So that's going to separate that side into 2. And those 3 feet, that height is just going to carry through over here. And what you could start to see are cubes forming. And that can be kind of tricky. Again, describing three-dimensional space on a two-dimensional figure is tricky, but can you almost imagine this block showing up here that's 1 foot, 1 foot, and 1 foot over there. So with that, we have this kind of unit cube coming through. And then I'm just going to continue kind of drawing these across here. And let's see, the width would break up the top there in half, like that. And this is where we could start to see our cubes coming through. In fact, you can see kind of this front layer of cubes almost, where we would have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 cubes. And then it's like we have a stack matching another 12 cubes right behind it. So that starts to get me thinking there should be about 24 cubes here. And I'm just going to write that down off to the side here. This isn't always possible to do, to draw this like this. These are nice small numbers to work with, but it gets us an idea of volume. What we could also do is, where I kind of described this layer at the front and layer at the back, you could also think of this base layer. And that's something I'm going to bring up again with other, this could be called a rectangular prism. We're going to hear the word prism come up more too. But this base layer where we have 1, 2, 3, 4 boxes, and then we have the second layer back here. So really there's this base layer of 8 boxes, or 8 cubes, let's say. And then with that, the height comes through, telling us the number of layers. So we have this base layer that's coming through as this rectangle that's 4 by 2. So we have these 8 cubes coming through there, and then the 3 feet tells us how many layers of 8 we're seeing. And that's what this image is breaking down here. What we can see is here is that base layer, and you could think of it as that rectangle that's 4 by 2. So 4 times 2 would give us that 8 right there. And then the height, which is 3, tells us how many layers we have. So with this scenario, there's a few different ways to think about it, but a way that can help, that we'll talk about more in the next videos as well, is that when you're taking volume of a prism, where you have kind of this base shape, and then you have this height to it, which is telling you how many layers you have, what you can do is, for volume, is take the area of the base and then multiply it by the height of the figure. So for our case here, and with every rectangular solid, that's going to come from taking the area of a rectangle, which is length times width, and then multiplying by the height. And that's where this formula is coming through here. You can just think of it too as taking the three dimensions, multiplying with each other. That's absolutely correct. It's just this kind of thinking will help when we start dealing with triangular prisms or trapezoidal prisms. When we start to see other shapes come through for the base object, this is going to help us out. So for our figure that we're dealing with up here, we're taking length times width times that height of 3. I'm just going to kind of separate that in a different color because I'll do that with the next videos too. So 8 times 3 is 24. And then for our units are in feet, and it'll be feet cubed because we're counting how many cubic feet there are. Same thing is true if you have a cube. So that's where all the side lengths are the same. It's like you're taking that base layer that's a perfect square, however many layers you have to it. You have this square, so you'd have s times s is s squared, and then you would multiply by the height, which is another s. So s squared times s, or you could just think of that as s times s times s, gives you that s cubed right there. So if you have a cube, you just multiply those all together. But if you have different length, widths, and heights, then you use this formula right here. Multiply them together and your units are cubed.